In this video, I want to begin our discussion of translation, which is the last part of the central dogma, where we turn mRNA into proteins. Before we can discuss the details of it, we need to consider the genetic code, its features, and characteristics. So I've written the 6 things that I want to talk about here. The genetic code is a triplet code that is non-overlapping and commaless. It's nearly universal. It's also degenerate and unambiguous. So what do all these things mean? Well, we start off this idea of a triplet code. The triplet code simply says that each codon is 3 nucleotide bases long. So here we have an example, AUG. So this actually codes for methionine, and we'll talk about why later. But it's 3 bases that make up a codon. Now, why does it need to be a triplet? Well, because a doublet wouldn't be enough. If we had combinations of just 2 nucleotide bases at a time, we would have 16 total possible combinations, and I've actually written them all out here. Now 16 is less than 20. Well, why does that matter, right? Who cares? Where did that 20 come from? The 20 is the idea that we have 20 amino acids. So in this case, the whole purpose of this genetic code is to have codons that code for amino acids that we're going to implement to make a peptide chain. So if we have 16 different possible codons, that would be less than 20. So we don't even have enough codons. There's not enough codons for all 20 amino acids. So the next smallest codon would be a triplet one. And why does that work? Well, because that leads us to 64 possible combinations, which is greater than 20 amino acids. So in that case, we do have enough codons for all 20 amino acids. In addition, the genetic code is also non-overlapping. So here, I've drawn an example of a code that is overlapping and one that is non-overlapping. What's going on in each? In this first one, there are 3 nucleotide bases that are read as a codon. The next codon is not the next 3 nucleotide bases. Instead, we only shift over 1 base and read the next of the 3 codons that are consisting there. So we don't read it as 1, 2, 3, and then 1, 2, 3. We read it as 1, 2, 3, and then this 2 now becomes a 1, 2, 3. This is not how it works in the genetic code. It is not overlapping. Instead, we just read it as 1, 2, 3, and the next are 1, 2, 3. Each of these 3 is a codon. This codon, or the way the codons are read here, there's no overlapping. So this is actually what happens with the genetic code. In addition, it is commaless. So up here I've drawn an example of it with commas, and here it's commaless. So commas, you know, kind of look like this, right? In sentences, they separate. They can be used in sentences. Anyway, the point is here that if you read a codon, if you read 1, 2, 3 codons, if there were commas, the next base would not be part of a codon. It would just be a comma in between the next codon. So here we'd have a codon, comma, 3 bases make up a codon, another comma. This is not how it works with the genetic code. There are no commas. So each base, they're just read sequentially. 1, 2, 3, that's a codon. The next 3, that's a codon. The next 3, that's a codon. This is how it works in the genetic code. Genetic code is also universal, and nearly universal. The reason that's there is because almost all organisms use this same genetic code. There are a few exceptions. So now these 2 ideas of degenerate and unambiguous. I put stars next to them initially, and that's because they can kind of give people trouble. So degenerate is this idea that each amino acid can be coded for by more than 1 codon. So what am I getting at there? Well, here's an example that may be helpful. If we're looking at isoleucine can have these 3 different codons. It can be AUU, AUC, or AUA. So let me actually show you what I mean there. If you look at this table, if this is our codon, first, second, and third base. So we just said we had leucine. So leucine, or excuse me, not leucine, isoleucine, sorry. So isoleucine could be AUU, AUC, or AUA. All three of these codons code for the same amino acid. That idea is that it's degenerate. So here we have isoleucine can be AUU, AUC, AUA. So if you have AUU, it will always be isoleucine. If you have AUC, it will always be isoleucine. AUA, it will always be isoleucine. But if you have isoleucine, you don't know if it's necessarily AUU, AUC, or AUA. Which this idea kind of goes hand in hand with the idea of the code being unambiguous, which basically is that each codon can only ever code for one amino acid. So an example here is that if we do have AUC, AUC will be isoleucine, or excuse me, will always be isoleucine. And it will never be anything else. If you look at the table here, if you have AUC, that's going to be isoleucine for sure. There's nothing else that it can be. If you have AUG, that will always be methionine, never anything else. So if you go to the table, AUG, that's methionine. It's never going to be anything else. But degeneracy, if I tell you that you have isoleucine, what's the codon? Isoleucine, well, you don't really know, right? It could be AUU, AUC, or AUA. That's the idea behind it being degenerate. So the code is degenerate, but unambiguous. If you know the codon, you know the amino acid. But just because you know the amino acid doesn't mean you necessarily know the codon. That's the idea between these two. Something else I do want to mention is that there's one start codon. That one start codon is AUG, and that AUG codes for the amino acid methionine. There are 3 stop codons, and those 3 stop codons are UAA, UGA, and UAG. How do I remember this? It's a little bit of a silly way, but if you think about somebody, everyone has like a friend or a little brother or sister or cousin or anybody that sometimes is annoying. So when people are annoying, you want them to stop, right? So you will tell them, you are annoying, UAA, you go away, you tell them to go away, and eventually if they do go away, you are gone. So UAA, UGA, UAG. Simple, silly, but it's an easy way to remember it. Hope that video was helpful in understanding what's going on with the genetic code. One last thing, I am a tutor. If you live in Southern California, feel free to contact me via email at moveuniversity@gmail.com. See the description below for more details. Thank you for watching.